All right. So Mofe Akinola is an AI engineer focused on building practical, scalable AI systems using low-code and cloud-native architectures. His work centers on designing intelligent automation solutions that integrate machine learning, deep learning, generative AI, and enterprise platforms to solve real business problems. He has experience developing AI-driven systems such as multi-agent business assistants, operational analytics tools, and workflow automation platforms that integrate with enterprise environments, including ERP and service management systems. Mofe is particularly interested in bridging the gap between theoretical AI concepts and production-ready solutions that organizations can deploy efficiently. If you're in the last class, I'm sure the we all experienced the class, and today it's going to be the continuation of this special session. So before I take too much of our time, I'll be leaving the floor for Mofe Akinola, our trainer for today. Mofe, are you there, please?
Good morning, everyone.
Yes,
I'm
good
glad.
morning. Nice to have you here with us this morning.
Same here.
Yes, sir. So you can go ahead to take over the class now. Thank you.
All right. Thank you. All right. Good morning again, everyone. Thank you for joining us for another session. And I hope that this one, well, I hope it only gets better from here. Due to your feedback from the last class, I will try to take things a lot slower and uh, be more interactive to the best of my abilities. Without further ado, I will share my screen and then we'll begin with the second session of architecting low-code AI solutions. All right. I would like to confirm if you all can see my screen.
Yes, we can see a screen.
All right. Thank you. Okay, so last week we talked about BigQuery ML. We touched on different aspects of machine learning and RAG and the Google Cloud platform that we'll be using to train our models. We also used basic SQL codes to create a model, evaluate, and make predictions. So for this class, I decided to take us back a bit and so we can really understand where we're coming from, and then we'll see where we're really going. So in today's session, we'll talk about the AI basics, and then we'll practically build a model using Vortex AI's Auto ML feature. Now, by the end of this class, or I will share some documentation when it's time for the practical, and then I would like us to open the zip file and have access to the data we'll be using for the practical class. Better yet, I will just start with that. So I'll send this zip file to the chat room so we can all download the file in preparation for that. So just give me a second. All right. So if you all look in the chat room, I have sent a zip file. That zip file contains three files. So you have your train data, your test data, and the assessment for last week's class. Now, during the practical, we'll focus on using the two files, the train and the test file. We'll upload that and we'll make our model using that information. So back to our slides. All right. So like I said, we're taking a step back so we can build gradually. So today's session, we'll understand basic AI, and then we'll look at Vortex AI, Auto ML, and how we can create our model using the UI features. All right. So the learning objectives are AI basics. We'll learn about machine learning and deep learning, and also foundation models. And then we'll build our very own forecast model using minimal code and using Vortex AI Auto ML capabilities. So I'll explain to us why we use Auto ML and what the traditional machine learning or deep learning techniques, require. So I'll show you what traditionally it looks like and then how easy Auto ML makes it for engineers and anyone basically who understands the concept to build models to serve business use cases. So a brief overview would be, what is AI? AI is basically artificial intelligence. It's intelligence that is made by man. It's made to do tasks that would naturally require human beings to do. So repetitive tasks that you would have to come into the office every day and have to write down or manually type information. We can use AI to either write the reports or fill out documents and so on, right? So it's come to make life a whole lot easier for us. And then we'll talk about machine learning. Now, machine learning is an aspect of AI where you take an already existing model and you train it to learn patterns from data, right? So you're training your model to be better for a specific use case. And we'll see more of that later on in the course. And then we'll also talk about deep learning. So deep learning is further specialization. So unlike machine learning where you are training or fine-tuning an existing model, deep learning involves you creating a model from scratch. And this is how most foundation models are developed, right? In our previous class, we talked about how vast foundation models are and how well trained they are on different use cases, right? So how we create those foundation models is using deep learning techniques. Now, I'll cover briefly what deep learning is and then we'll move forward. And again, what are foundation models? They are models that are designed to on multimodal data and can cover as much use cases as possible, be it text generation, be it object detection, be it image generation or code generation. They are well versed in all those different use cases. So why does AI matter? AI has come in the sense that it has come to transform a lot of industries. We are now using AI to do a lot of things that naturally it would have taken 10 people to do, right? AI does it in hours. So it's come and it's transforming the way people work in day to day. the automation benefits are immense. We are automating almost everything now. For someone that writes code, for a software engineer that has to do with a lot of code, now he doesn't have to manually write the code anymore. He just needs to make sure that whatever code is being produced works and is clean and is secure and it serves the purpose that it is produced for. So it's reducing the manual work. We are not having to write our reports manually or type them in or fill in our Excel spreadsheets one by one. We have AI that can automate the entire record process for us. So, and then there is a growing demand. I say as human beings, as long as something makes our life easier, there's a chance that that thing is here to stay. So I think AI has come to stay, and I think it's going to change the way we work now going forward. So as an individual, I think this is the best time to really get into AI and really understand what it is about and how we can use it in our day-to-day. So we'll start from foundation models. This is a more detailed explanation into what foundation models are. So I say foundation models are the bedrock of AI, right? They are what start off basically give us the freedom to do a lot of the things that AI does today. Because without those foundation models, without the investments made by all those big companies, we wouldn't have ChatGPT or Grok or Gemini. We wouldn't have all the features or the functionalities that they give us today, right? So, and those foundation models are generally created by using deep learning. Now, I'll talk more about that later, but it is deep learning allows us to create our models from scratch using the data that we want to train them with. Uh, excuse me. All right, apologies. Apparently, I am still fast, so I'll slow down some more. Okay, so I was saying that foundation models are the bedrock of AI development. Now, because those models are developed on such fast data, right, they are able to complete a numerous amount or complete numerous tasks depending on the user's query, right? So how those foundation models are created is by using deep learning techniques and deep learning frameworks. And we'll also talk about that later. So we use deep learning techniques and frameworks to train our models on the data so they can perform the task that we want them to. Now, if we decide to fine-tune a foundation model for a particular use case, so it could be you want to implement AI into a financial company, right? You need to make sure that that AI model is well versed on financial terms, techniques, and different patterns. And that's where machine learning comes in. So after you've created after a foundation model is developed, if we want to now fine tune it for a particular use case, which is, for example, a financial company, we have to now use machine learning techniques to train that model so that it learns patterns from the data, and that when a user decides to use that fine-tuned model, it already knows information about the domain, which is finance, right? And that's where we now get our icing on the cake. That is a fine-tuned artificial intelligence model for our use case. So again, foundation models are the bedrock for AI development, and they are done so that we can have access to such intelligent systems. Okay. So let's understand what the difference in AI model development is. So when you say you train a model, you're building a model from scratch using massive data set. And that's when you say you're building a foundation model using deep learning techniques. Now, another another development technique is fine tuning. Now, this is when you decide to take a foundation model, right? So that is a pre-trained model, and fine tune it for a specific task. So it is faster and cheaper. So basically this is saying is, instead of creating a foundation model from scratch, which is very expensive, it is a lot easier and cheaper to fine tune those models, those already existing models, to your use case or for your specific task. So most of the companies today that don't have the funds or the resources to build a foundation model from scratch end up just fine-tuning the likes of ChatGPT, Grok, Gemini, or Microsoft's Copilot for their specific use case. So think of it like this. Training is like building a brain. Fine-tuning is like teaching that brain a specific skill, right? So So I hope we understand that. So this is what it takes to this is what it takes to train and develop a foundation model. This is the workflow that is involved. You start with your raw data. So it could be data, it could be images, text, it could be code. Really, it could be any form of data that we could think of. It could be voice, speech. You could literally train AI with audio content, and it can generate or replicate that audio content for you in a different voice, in a different tone, different gender. So it's that intense. So once you have your data gathered, then you clean your data to make sure there are no anomalies or outliers or incomplete or null values, right? Because all that does is ruins your training. If your data has a lot of outliers or incomplete values or roles where there's no information, it ruins the training process. And then you start to have big errors in your loss function, or your predictions are completely off. So it is very essential that once you have your raw data, you clean it. And after you clean it, you turn that data into tokens. Now, I mentioned before about tokenization and how we are turning text into numbers, images into binaries, ones and zeros, so we can see the pixels, so the model can understand what that image is saying. So basically, we're turning our data from its raw form after we cleaned it into tokens so that our model can understand and learn from the patterns. Now, I'm not going to go into details on how the model really understands the numbers, but computer works better with numbers. So we'll leave it at that. And then after we've tokenized our information, our data, we develop a neural network where we'll pass the data through it. And then once the data comes out, or after the model has learned the information and the patterns from the data, we have our AI brain, which is what we have here, right? So this is what we have. This is the ChatGPT. This is what Grok is, and this is what we have for Microsoft Copilot. This is the process involved in getting to that end goal. So foundation model use cases. Now, because they are so well informed on different forms of data, right? We can use them for our backend for our chatbots. We can use them for medical diagnosis. We can use them for coding assistance and finance tools, right? And basically what this is that after you have your foundation model from the previous training, we can now fine tune them using machine learning techniques so they can serve for our chatbots. We can use them because you can't just use a foundation model to make medical decisions, right? People's lives are at stake. So it needs to be well informed on the different, terms, methodologies that are involved in the medical sphere or domain. Same for software development. We need to make sure that the model is well advanced in code writing. And for financial tools, just needs to know the metrics, needs to understand the calculations and the formulas and so on. So, but like I said, foundation models are at the core of AI and they are the bedrock. Everything that happens after is what gives us what we can interface with today. So why training AI is expensive? Now, it takes a lot of things to, put get the foundation models out. It's very expensive. You're talking about developing data centers. You need to have your data centers have to have the hardware installed. So the hardware requirements include GPUs and TPUs. GPUs are just the graphic processing units, and TPUs are the tensor processing units. Basically, all they do is allow the training process to work or move as efficient as possible, right? If we decide to use a CPU for a training process, it will take us days and hours, weeks just to get the same results than if we just use a GPU or a TPU. So those features, this hardware, they don't come cheap. They're very expensive to maintain, to have, and to even use, right? And then the operational cost. It takes a lot of electricity. So a lot of data centers have their own power supply. They have their own solar plants or gas plants because you need the electricity supply consistent. You can't rely on the grid because if there's a downtime at any point in your processes, you could either lose all your training data, lose all your models, or you have to start again. So it's very important to have stable electricity, and stable electricity means high operational cost. And then your team size, I know I said that AI makes life easier, for the end users, but for the people that work behind the scenes to get us our foundation models working like they should, they need to be well adversed, right, in the techniques and the frameworks used. They need to understand the way models work. They need to, be efficient. And those team members definitely do not come, well, you pay a lot for them, basically. You pay a lot for the services because it's not easy work. So that's why it's better for, end users like us to, just fine tune the models and have them working for our use case instead of we leave all the hard work to the people in their domain, in this tech domain. All right, so what are the core components of AI? Core components include your data input, the training process, the evaluation dashboard, and the deployment. So we've talked a lot of workflows, and that's what it is. There's a process to everything in AI. You can't start from the end and or the middle and expect to get the same result. You have to make sure your data is processed right, your training process is selected right. So your models, are you getting the right data in right feature engineerings. And after your training is complete, you have to make sure that you evaluate your model. You have to make sure that your metrics are well accounted for. Your metrics, your evaluation metrics are not off. And we'll look at that in the practical class. Then after you're done evaluating your model, you deploy your model, and then you start using it for the different use cases. And that's what it is. So now we'll briefly introduce machine learning. And machine learning basically is how models learn from patterns to make predictive insights, right? And what BigQuery ML, what BigQuery ML does and what Google Platform provides us is we can do machine learning, right? We can train a model from scratch without having to write a lot of code. And they have automated the entire process that would have taken us hours to do. So machine learning, like I said, is just we're teaching our model new tricks based on the data that we feed it. So when it encounters a different type of data, it can make predictions, or it can tell if the information is fraudulent or not. We can tell if a customer is going to likely leave our services before the customer even decides to leave our services, right? So those are the predictive use cases for AI, and we do all that by machine learning. So there are different types of machine learning categories. You have the supervised learning, which is where, with like the name implies, supervised learning requires a human, or well, requires us, the engineers and the software engineers, to monitor the learning process for the model, right? So we supervise the learning that the machine or the model learns from labeled data, right? So we're going to feed the model, uh, basically we're going to fill the model, we're going to feed the model questions and answers. And then the model learns from the questions how to answer. It learns from the questions and the answers, and then it can answer new questions based on what it has learned before. So if you give it how do I put it? If you give it, for example, my company's Q&A pairs, if you have questions, what does my company do? You have the answer on the next line, right after the question. If you give it 10 question and answer pairs like that, the model already learns the question and how to answer it. So when we ask it a similar question, or a question that slightly differs from what it already knows, it knows that the answer is most likely going to be, okay, the definition of what my company is, right? And I'm hoping that along later on in the course, you start to see and you really understand what it is, right? So there are different types of algorithms in supervised learning. You have the linear regression, which you use to predict sales and prices, and you have the logistic regression, which you use to detect spam and fraud detections. Right. So we also then have unsupervised learning. And for this, it doesn't require constant human input, right? The machine finds the patterns on its own from unlabeled data. And when you say unlabeled data, it means we just feed it a lot of questions and we tell it to make predictions, right, on what the answers could be, right? So that way it's learning constantly and over again until we get zero on all our metrics. So I'll explain what I mean when I say zero on a lot of our metrics, on our evaluation metrics. So an algorithm in unsupervised learning could be the K-mean clustering, which is used for customer segmentation, you segregate your customers. And then we talk about reinforced learning, which is where the model learns through rewards and penalties. And what that means is during the training process, if the model gets an answer right, you reward the model. You give it, you could use code to reward it. There's a way you do it that you can give the model a reward, in a sense that the model, a way to acknowledge that like giving it the thumbs up in this, for example, like when you say you like a YouTube video, when you click a thumbs up in the model's response, it means you're rewarding the model for that decision. or you can penalize it by giving it the thumbs down, meaning that it got it wrong, right? So that's reinforced learning. And then an example will be Q learning using decision-making systems. And then finally, we have transferred learning. This is where you take the learned parameters from a previous training exercise, and you take that parameters and transfer it to another model that hasn't been trained. But because you have transferred those training parameters, that new model now knows what the trained model knows. I hope you understand what that means. So now you have two models, one trained, one that's untrained. We take the parameters from the trained model and add it via code or using our frameworks and add it to the model that wasn't trained. And just by that, that model two, you could say has been trained because it now has the knowledge that model one has. So those are the different categories and different learning types in machine learning. And then we'll move forward. All right, so this image just shows us what the basic machine learning workflow. You have your data set, then your machine learning model, and then your output predictions. Naturally, all this is a lot more complex than what this image implies, but because we have a lot of automated services like Google Cloud Platform, we can look at the entire machine learning process as simply and straightforward like this. We're just having three main points. And you see what I'm talking about later on. All right. So what are the key concept or key elements in machine learning? There are several key components, and one of them is the features. And those are usually the input variables, like the age or a price. And I'll show you that when we look at our data set. And then the label. These are usually the target outputs we want to predict. So just think about features are like the column, right? And then the labels are the values inside the rows, the values inside those columns that we're trying to predict, right? So you have your training data, which is used to train the model, and you have the model algorithm. So depending on your use case, you determine the different type of machine learning model or model that you want to train. And so each model has the different, procedures and techniques and code bases. And then your predictions are what the model's output after it has been trained. So basically what we're trying to see is, are the model's predictions close enough to the labels? And if they are, good. If they're not, we have to train our model again until we're sure that our predictions and then the labels from our test data are as close or are the same, right? Only then can you say that your machine is well trained and is deploy ready. So in short, it's about learning patterns from data to make predictions. So we're learning from our features and our training data, and then we'll make a prediction and see if we get it correct or not. All right. So another aspect of AI is deep learning. Now, like I said, deep learning is how our foundation models are generally being created. Right. Now, this image right here shows us what it takes. So image right here shows us what it takes. All right. What a basic deep learning workflow, or no, basically this image shows us what a model looks like. This is a more technical representation of what our ChatGPT looks like before it gets to that UI, before we before it gets to that UI stage which we interact with. This is what the backend basically looks like. This is what a foundation model looks like at the beginning, right? Before you can start answering questions and so on. So we naturally have three layers, right? Which is the input layer, right? The hidden layer, and then our output layer. Okay. The input layer refers to the stage where we input our clean data. So after our data has been cleaned, we run it, or it has been turned to tokens, we run it into our input layer. So this layer accepts that information and then passes it into our hidden layers. Now, you could have one hidden layer, you can have 2,000, you can have, honestly, you can have 200. It depends on how big your foundation model is, but you could have a lot of hidden layers, and each hidden layer has a node. And this is what I call a node, right? Each node has its own computization or computation code inside it, right? So each node has its own computation setup, right? So it knows what it's looking for, basically. It's designed to attack certain features or parameters from your data and then process it, learn from it, and then it passes it to the next hidden layer. This layer two, this node in this layer has its own computation, its own code, and then it does the same thing, right? Processes the data, learns from it, analyzes it, and then it passes it again onto the next layer, which does some further computation, some more, understanding, pattern learning before it passes it back finally out to the output class. When it gets here, the output layer, this is when we can start to see that if our model is making sense or not, right? As our model learned anything. So basically what it's saying is this 0001, now that it has passed through our model, I'll classify it as product A. 020002000210003. Now that it has passed through, I can classify it as product B. So I'll break it down even more. Think of it like this. As human beings, we have our eyes, our brain, and then our mouth. Think of your eyes as the input layer. Our eyes takes in the information that we see, right? Sends that information to our brain, which is our multiple hidden layers. So we sends that information to our brain, and then our brain processes it. Now, I'll talk more about this, but our brain processes the information, tells us what we're seeing, tells us what color, tells us how it looks. And then once it's done processing it, it sends it to our mouth, right? Which is the output layer. So our mouth now can now tell us or talk to whoever we're talking to about what we saw, or we can explain what we are seeing. So just think of it as that. And honestly, if you can understand this, I'll move on. If not, I can go over it again. But the next slide, I'll explain more about what it is. So remember, deep learning is how our foundation models are generated, and they involve three main layers: your input, multiple hidden layers, and your output layer, right? So more fun. So uh, the entirety of everything here is what we call neural networks. So you're connecting different nodes together, different patterns. So this node is connected to this and is also connected to this and this. So basically everything is connected. And where we humans got the idea from is our brain, like I said. So I talked about how our brain processes the information that we see, right? The neural network was inspired by the human brain, consistent of interconnected nodes. Now, the way our brain works is after our eyes take in information, right? There are different nodes and different neurons in our brain that processes the information so that we can understand it before our mouth starts to, speak about it. So understanding the fundamental of how neural network works is basically just saying, I think of it as a human brain, but it was a brain made by humans, right? The idea was gotten from our own human brains, and us humans just developed and developed using code and different other features till we could get the artificial AI or artificial intelligence that we have today, right? So the layers consist of input layers, several hidden layers, and an output layer. And then the model automatically learns from complex patterns from large data sets. Right, so now we'll talk about AI frameworks. There are different frameworks. And when I say frameworks, frameworks basically are tools that help machine learning and deep learning engineers develop our models, right? So they are basically a bunch of tools that are designed to make the entire workflow easy. We're not having to write several lines of code. We can just call a function, call a tool, call a library, and then that library does what we need it to do. So let's say we want to evaluate our model. We can just call the model.evaluate function, right? Or tool, and then it would evaluate our model for us and give us our results. So there are different AI frameworks. There's TensorFlow, right? There's TensorFlow, PyTorch, JAX by Google, and skitlearn, right? All these frameworks work individually. So you can either be using TensorFlow, PyTorch, skitlearn, or JAX, but never do you really use so many frameworks together. I use mostly PyTorch and skitlearn for machine learning. And hopefully one day we'll learn TensorFlow as well. But right now, that's where I'm at. So basically, all these frameworks just make machine learning easier to do. Traditionally, you have to write the code for each hidden layer, and then you talk about each parameter for each hidden layer. But nowadays, we don't have to manually write those codes. All we have to do is run it through a platform like Google Cloud, and we have our model trained, right? So I'll show you that later. So more on our frameworks. So TensorFlow is a production-ready ML framework that supports both research and deployment. PyTorch is known for its flexibility and is favored in research environments. And skitlearn is often used for simple, efficient tool and data mining analysis. So we use skitlearn a lot for machine learning basics. PyTorch and TensorFlow are used mostly for deep learning, right? That's when you really want to, develop your own model. So like a finance company now will want to, let's say they want to develop their own model, right? They have the funds for it. They would have to hire engineers. They'll have to, get the hardware, so the GPUs or the TPUs, and then the engineers will then use the PyTorch or TensorFlow frameworks to develop their models based on the company data, right? So that's what frameworks allow us to do. And then we'll talk about hardware for AI. Now, like I said, hardware is an important aspect of AI development. They determine how fast you train your model and how efficient you train your model. If you use a CPU, naturally it'll be very slow because CPUs are not designed for machine learning or AI development. When you start to develop AI, that's when you start to use graphic processing units and tensor processing units. They allow for parallel processing speed, so they're a lot faster than the CPU. And then the tensor processing units are designed specifically for machine learning and deep learning. So they are designed so that the AI learns in an efficient workload manner. So to understand the fundamentals, we need to make sure that, so basically more compute power. So the difference between a CPU, a GPU, and a TPU is that they give you more compute power. And more compute power generally means faster model training and enhanced capabilities, which in return leads to better performance of the model on a greater scale. So you can easily scale up your model with better computing power, which is what GPUs and TPUs provide. Right? So why do we run AI on clouds? So you could run AI locally with your hardware. So like our finance company, for example, they would have they will need to have the hardware on their site, and then their AI agents will continue, connect to that hardware and then start to develop using that running hardware instance, right? But what we have today is a lot of companies are giving us cloud platforms that we can develop AI in. So why do we run AI on cloud? The advantages include when you utilize cloud platforms, it enables team, to break that cross. So you could have people in different parts of the world working on the same model training. Just because the hardware and infrastructure is online, all they need to do is log into the platform and interact with the model, right? So there's no need for us to buy expensive hardware. Those cloud platforms already provide computer cloud virtual CPUs and virtual GPUs for us to use and train our model, right? It allows us for easily scalability. Most of these cloud platforms have the built-in tools. So for example, our PyTorch and TensorFlow libraries or frameworks are already installed in most of these platforms uh, developments, right? So we don't have to manually install them again. All we need to do is just call the right function, call the right tool, and we can have our model training in moments. So there's faster experimentation and iteration cycles, and then it definitely reduces the setup time. So basically, it's more efficient to run your or train your model using the cloud platform. But if you have the funds for it, you have the resources for it, be our guest. Uh, put your resources and get your model trained. And then cloud platform also help. They remove a lot of limitations for collaborative work. They allow for flexible training, and they're developed to have efficient environments, which are essential for AI projects. So they give developers a lot of, flexibility, and you can do a lot because you can have different types of GPUs running, you can have different types of TPUs running, you can use the different types of models. Everything is just, developed as an infrastructure that we can easily interact with and get our productivity up and as quick as possible. And honestly, with less funds and less resources than it would require to have your hardware locally or on-prem. Now, they have different types of cloud platforms. You have the GCP, which is Google Cloud Platform. You have the Amazon Web Service. We have the Microsoft Azure. And but like I said, we'll be focusing on the Google Cloud Platform. And as you can see in the image, it just shows us the different data centers and how there's an interconnectivity between the different data centers. Basically, the world is connected more than ever today, and largely due to AI. So like I said, we have the cloud, Google Cloud, Amazon Web Services, Microsoft Azure. And basically what they do is this platform provide an end-to-end machine learning platform. And this is where tools like BigQuery ML and AutoML live. Now, basically what this image shows us is what traditional machine learning pipeline would have looked like before we automated all those processes. You would have had to manually clean the data, manually feature engineer, and then you select your model. And then you see that in this image right here, there's a lot of moving parts, honestly. See, there's a lot of moving parts. So many things need to do manually. So it was complex before. But now what this cloud platforms have provided for us is a streamlined workflow where we get our data cleaned, we run it through the automation engine, and then we make predictions. It's really that straightforward. So naturally, your productivity increases, your efficiency increases, and your cost drops because you are producing a lot faster than you would have before the automations began. All right, so now that we understand basic machine learning and deep learning and foundation models and what it takes to, run our models in cloud and why it is expensive and why it's better to use cloud. Let's now look at one of the cloud services that Google Cloud Platform provides. Now, last week we looked at Google Cloud's BigQuery, which is where we made a model using some SQL code and we evaluated the model and so on. Now, in the folder that I shared at the start of the class, there is a Python notebook attached to it. So a Jupyter notebook attached to it. So what we're going to do at the start of the class is we're going to import at the start of the practical, we're going to import those three files, and then the Jupyter notebook will be your assessment for after the class, and basically it will just help you replicate what we did in the previous class. Now, and then the data there is also attached, so all you need to do is rename your data and run the SQL code, and you should have your own trained model ready for predictions and testing. So, but let's focus on Vortex AI and the Auto ML capability. So Vortex AI is another service that Google Cloud provides, and the Auto ML is how we automate the entire training process for our model. Now, in BigQuery, we wrote code. We wrote SQL code to train our model, to create our model, to evaluate our model. In today's class, we're not going to write any code. All we're going to use is going to interact with the user interface, and then we're going to create a model, right? And then we'll evaluate the model and see what our metrics are saying and see if we need to better, train the model again or clean up our data, or we'll see more of that later. So what Vertex AI AutoML does is it helps us automate the entire training process, and we're going to see that in the practical class. So the processes involved in building an AutoML model is your data preparation. We'll clean our data, and then we'll ensure that all the variables that we need and all the features that we need are already defined. We'll determine what type of model we're developing, and for this class, we'll be developing a forecast model, and then we'll make predictions, but we'll keep the predictions for later on in the course. So we'll train the model, and then we should see our model trained and our metrics, our evaluation metrics after the model is trained. So the key requirements include you can clean our data, or determine our target variable. So what I mean by target variable is the variable we're trying to predict. So for this case, we're going to be trying to predict the sales. We're going to try to see what our sales would be like in the future based on what our sales are today, right? So you look at the feature columns. Feature columns basically involve what columns directly affect our target variable, right? Is it the store ID? Is it the date, store number, and all those things? And then another important factor is the time formatting, right? We need to ensure that because it's a forecasting model, a time column or the dates column is very important, right? We need to either make sure we're taking the dates, but monthly, weekly, hourly, or whatever format that we choose, we have to ensure that it's consistent throughout, so it doesn't disturb our training process. So there are different supported data types. You could have tabular data, image data. Tabular data refers to our Excel spreadsheet. Image, just a bunch of different images coming together. Video, like the different videos. Text, basic reports. Speech is when you want to either transcribe your voice into text, or you want to transcribe text into voice, right? So we either load the model with different people's voices or with different speech patterns in a sense. So we're moving on to forecasting future values with AutoML. So AutoML forecasting allows us to predict accurately the future values based on their historical values, right? So because we can predict what our sales will be like in the future, it allows us to plan in that direction. I give an example of when it's raining and then a taxi company, if our model predicts, okay, uh, on this particular day, it will rain, and because it is a Monday, there's going to be a lot of people outside. So a CEO for a cab company would use that information and then decide to release a large number of cabs on that Monday because it's going to rain, and because he knows it's a Monday, if he had 50 cabs running in Lagos, we'll do 100. And just by doing that, you're going to be able to get more customers And because you're getting more customers, what's that word? Your funds or your value is increasing, you're making more money, and all because you were able to, predict into the future using AI models. So that's how they help us. So there are different types of problems and use cases for predictions. You can use it for retail forecasting, where, like I said, you predict your sales into the future. Energy prediction. So based on previous energies usage or supply, are we going to see, is the usage or supply going to drop or increase? Is demand going to increase or drop? Transportation planning, like our cab company, agricultural insights, the time of the year. I'm sure farmers will really understand how their crops grow, but if you add some analytics to it, you could really fine tune and, prepare better and have a lot more yield than you would have had without the analytics that machine learning provides. Financial forecasting as well, helps you make business decisions, financial decisions, and so on. All right. So we're about to begin the practical aspects, and this is where we're going to hands-on build a model using the Vertex AI machine learning interface. I hope that from last class we have all, well, if we haven't, we'll need to open and activate a Google Cloud Platform account. So we just need to search for Google Cloud and then open an account, and then we'll create a project. So once I'm done with the slides, we'll begin the practical. So the practical workflow will include, we'll create our data set, we'll configure and choose our training model, we'll determine our targets, then we'll evaluate or make our predictions, review our metrics, determine our continuous improvement, which will help decision making. And then we also debug our model. So we'll see why our metrics are so far off. Generally, most of the evaluation metrics is always better to have zero. But if we're having high values, it means our predictions are going to be incredibly off. So it means that we have to debug our model. We need to see why our model isn't making our metrics are so off. And how do we make our metrics a lot better than what they are? So there are common issues that we need to look for. We need to make sure there are no missing features or incorrect timestamp or irrelevant features, insufficient data or imbalanced data, right? Insufficient data meaning we don't have enough historical data. Imbalanced meaning we might have enough data for 1 year, and then the next year we have 2 rows, which is inconsistent, right? Then incorrect timestamp, if the timestamp is wrong, if we're going from 2013, 2014, and then the next file says 2001. It's incorrect. There's an incorrect flow, and that could ruin our training file. And then when we have irrelevant features, so irrelevant features in the sense that they have no relation to our target value, which is for us a sale. So if we leave those irrelevant features in our data, it's irrelevant information our model is learning. It's not directly, it doesn't directly affect our sales. So it's going to throw our models predictions way off. All right. So that being said, I'm going to pause here, and then we will take a look at the folder I sent. So if we haven't, please, I would appreciate it if we can all download that zip file, right? And then look into that file and see what we have, that folder, and see and extract the data from it. I'm going to stop sharing my screen now, and then we'll prep for the practical class. Before we go into that, I'd like to ask, are there any questions? Is there anything you want me to go over? Is there anything that you need better explanations? So we can really do this before we get into the practical class, so you really understand where we're going to, and I hope you understand where we're coming from. Hello, guys. Are we here?
Yes, we are here. No question.
Do we understand everything so far?
Yes, so far, so good. Yes.
All right, that's good. So, like I said, thank you, Tony. Thank you, Amaka. So, like I said, we are going to do our practical. I would like everyone to kindly download that zip file. And if we have, kindly let me know so we can proceed.
Okay, I'm using my tablet to log into this class. My laptop is dead, so I cannot use my tablet to download that file that was sent. Can it be sent to the class WhatsApp page?
Not a problem. I'll also forward it to
All
our
right, thank
host.
you.
Yeah, and
All right,
we should try to get it around.
okay.
All right. Like I said, this is going to be interactive practical session. So I'm going to take
Here's
each
something.
step. Sorry. Um, okay, well, like I said, we're going to go over each step together. I provided you the training and the test data sets. So all we need to do is upload them into our Google Cloud platform, and then we start to train our model with it. Now, I will lead the way, and if there's anything, let me know, stop. But before we go ahead, does everyone have access to the file? Because I'll wait till we all have access to that zip folder. Nice. Thank you, Patricia. Anybody else? Do we have the folder downloaded on our laptops, tablets? I'll wait. I really will. I want this class to be as practical as possible, so I'll wait until the host tells us not to. Nice. Thank you, Tony. All right, guys, come on, let's do this. All right. So all I want is just download the folder to your laptops and extract the files. Once the practical starts, I will walk you through each step because so that you can follow directly. So all I need you to do now is get the folder on your laptops and then we'll proceed. I'll give us a couple more minutes because I'd like us to close on time today. I don't want us to rush. So as soon as we're ready, as soon as a few more people have the folders and they notify me, we'll get straight into the practical. Uh, Jessica, it'll be difficult to use your phone, so I think it's best to use a laptop or a tablet. Right. But you could always learn now and then practice it later if you don't have access to your laptop right now. This class is, recorded, so you can just follow it again. All right, nice, nice. I see you, John. Thank you. Yeah. That's fine, Alenka, that's okay. So yes, the steps will be shown as long so you can practice it later. But try to follow along so when you're doing it after the class, it'll be easier and you'll be familiar with the workflow. All right, I'll give us 2 more minutes and then we'll begin. That's fine. That is okay. Like I said, just try to follow as much as you can. So when you're looking at it later, it's not all new to you. We'll also be using very little code, so you should be able to find your way around it. All right, well, we'll have to continue now, but I'm hoping everyone else will has access to the file, and if not, please do so and try to follow along. All right, so first of all, we'll start with creating a Google Cloud Platform account. And if we don't already have one, it's very easy. And I'll walk us through that briefly, and then we'll get into what we need to do today. So I'll share my screen and then I'll begin. I hope we're all ready for this. All right. So I'll start again. So all you need to do to get a Google Cloud account is all right. And I'm already signed in, but if I had to sign out, it'd just be like signing into Google, to be honest. It's really that direct and simple. So once you sign, just go ahead. No, can't do that. So once you've signed in, all you need to do is click on the console button right at the top of your screen on the right side. And that gets us to the Google Cloud Console landing page, right? And if you haven't before, you need to create a project. So if you click up here to your left, you can create a new project. You can name your project what you want, and then you create it. Once you create that project, it will naturally pop up here on the list of projects that you have. I won't be doing that, but I'm already going to work in the same project I was working with last week, right? So this is our project landing page, and this is where we see all the different services that Google Cloud provides. You can create a virtual machine, run a query in BigQuery, deploy an application, create a storage bucket, a lot of other things, right? And so all the products that they offer which allow the platform to work the way it works. All right. So we can even see here on the top of our screen our project number and project ID. So when you're practicing this after the class, you could always find your ID here, right? Because you will need that when you want to run your SQL codes for the assessment. So, but today we're going to focus on okay. So if we use our navigation bar, we can easily just go to Vortex AI right here. So this is what we're going to work with today. Vortex AI, and we'll click on it. It naturally lands us in Vortex AI Studio. We played around this last week, but we won't be doing anything with it today. Today we'll focus mainly on uploading our data to our database on BigQuery, and then we'll create a data set in Vortex AI, and then we'll train our model with that data set. And then at the end of this process, you should have a trained model loading. We will not be able to fully see the result during the period of this class because it takes hours for your model to train. I trained a model for almost 3 hours last time, so it takes a while. But I will show us how to get to that point and what it looks like after the model is done training. So like I said, we'll start with our database. So permit me is that if we're following, if you go to your navigation bar, you see all the services we're going to work with on the left. So we'll start with BigQuery, right? And then we'll work our way to Vortex AI. So let's start with BigQuery. Okay. And then if you have created a project and you are clicked on BigQuery, you should see your project ID up here in this folder or with this drop-down feature. Once you click down, you have the different folders that are in your project, your repositories, your queries, your notebooks, data canvases, data preparations, pipelines, and connectors. Right. Okay. This is all right, here we go. Okay, so now we have the different folders. And if you notice from last week, this is the same data set from last week. But I'm going to show us how to create a data set, right? And then we'll upload our data into the data set. And we'll also upload the notebook that is inside that folder. So we have 3 files in that folder, and we're going to upload all 3 of them first. So naturally, if you can see my screen, this is the folder that I shared. Uh, and you have 3 folders, 3 files in that folder. So what we're going to do is we're going to upload these 3 files using Google BigQuery. And then we'll reference those files in Vortex AI. All right. So let's find our files and let's upload them to our BigQuery console. So on your project, you click on the 3 dots and then you create a data set. We'll create a data set and call it a this is our database ID and our location. Now the location is very important because I mentioned it last week, but your location also determines where your data is stored as well. And it's always best to use a data location that's closest to you or your client. But it's also good to know that some data set locations don't have certain services that we might be needing. So I use two data locations because they work and because one of them is the US one and it has a lot of services that we will need. And the other one is Europe West, which is the closest data center to us here in Africa. The one in South Africa doesn't have a lot of the services that we would require, so I don't really develop in that data location. So like I said, we have see, this is our closest one, the one in South Africa, but it's not as, detailed as we would like. So I use US Central, right, as the first one, US Central Lower, or Europe West for Netherlands, right? So I think for this class, it's best to just use the US Central. So we keep it efficient enough and we have all the services that we need. So you can go ahead and just create the US Central location and then you create your database, all right? Your data set. So here we have our data set. Our data set is here. And as you can see, it's currently empty, right? This AIAS class is currently empty. I clicked on it, there's no tables in it, there's nothing. So the next thing for us to do is to create a table, right? So we'll use the UI and click create a table. All right. So what kind of table, where are we going to get our table from? We're going to upload it from our local laptop. And now we're going to look for that file. So the first file we'll need to do is all right. So if you extracted the folders, the first file we need to do is our train data. So we'll upload our train data. All right. CSV file. This is our project ID, the name of our data set, and then the name of our table. So I'll call it forecast train data. Right? So we know that's our train data. And then we'll click auto detect on the schema. So our model, the import knows that our table uh has table headings, like so each column has a heading, right? So it auto detects that. If we don't click this, we might not be able to import our file. So we click that, leave the rest as it is, and then we create a table. Um, So as we can see, our table has been created. If we come back, we should see our table right here. So there we go. So just refresh and we see our table right here. All right, so this is the first table we imported. Let's import the next table, which is our training. So upload, select files, test. So we put our test data now. And then same project ID, dataset class, and then we'll name it forecast test data. So like I said in our previous class, also we auto detect, leave the rest that it is, and we create our table. Like I said in our previous class, it's always good to divide our data set into our training, which is what we used to train our data with, and our testing, which is what we used to test if our model is efficient enough or if our model makes the best predictions, right? So now that we've imported both files, we have both tables in our data set. That's fine, but we have zero models. And so what we're going to do now is we're going to create a model. But before that, we're going to import the last file, and this is for your assessments, right? So you go to the notebooks, right? And you will click on the three dots and upload notebook. So we're going to browse for our notebook, our BigQuery lab notebook. And then we're going to open that. We're going to pick our location as US. So and always pay attention to the location. It's very important because you could, okay, I'll slow down. So while we wait, I'll just briefly walk us through what the content of that notebook is. We have an end-to-end. So you can see that we have an end-to-end ML lab BigQuery, right? So you will see your project setup, you create your project, ensure your region is correctly selected. Then you open the BigQuery console. All right, so you create a data set just like I just did. You create that data set. You can either use the UI or use the code, but I think it's a lot safer to use the UI. You import your data like I just did, your train table, your test table. Then you can explore the data using SQL code. So remember to fill in your project ID here and the name of your data set. So whatever you call your data set, I called ours AIAS class, and then the name of your table, which is train table for me, could be something else for you. And also remember to fill that information here as well. And then this is where you feature engineer, you create certain views. So it's basically a different look of your original table. If you want to combine two different columns together, you can do that. If you want to remove certain columns, you can do that. But all you need to do is just run this SQL codes and you should get your desired outputs. And then you train your model with this code as well. Remember to make sure that you're referencing the right data sets and the right project ID. And then once you run this, you should have your model created. And then you evaluate your model to see if it's trained properly, and you make a prediction. So this will be your assessment, but you can walk through it and you can reach out to us if you need any help and you will assist. This is also the AutoML walkthrough. So this is what we're about to do and what we're walking through. We've created our data sets. Now we're going to train our model using the trained data. We'll configure the model, and then we'll deploy the model and make predictions. But we'll keep the step 4 and step 5 for later on. So if I can continue now, I hope that I can. So now that we've selected our Jupyter notebook, okay, good. Thank you for Shisha. So now that we've selected our Jupyter notebook, determined our location, we'll upload it. So by uploading it, you should see it here. There you go. Now you have your notebook. If you're going to run, now you have your notebook. And all you need to do is run all these. This is how you run on Jupyter Notebook. If you click on it, it should run. Oh, no, better yet, it's best to copy this code, right? It's best to copy this code. This file is just a walkthrough for you, but it's best to copy this code and run it in your queries. So you create a new query, all right? And then you paste the code in here and you run it. But more on that later. So let's stick to what we're doing right now. So now that we've uploaded the 3 files, let's connect our data sets here to our Vortex AI platform, and then we can start building our model. So again, navigation, we'll just go directly into Vortex AI datasets. Now the two, so we're going to create a new data set based on the data that we uploaded into BigQuery ML. So let's create a data set in Vortex AI. So the thing is there are two different services, but they are connected, right? So we'll name our data set uh, data set, right? And then what type of data is it? So our data is tabular and it's for forecasting, right? There are different types. There's a single label, multiple, object detection, segmentation. We're going to just use our forecasting, and that's what that's the type of model we're trying to build. So it's going to be forecasting data, right? We'll pick our region, the same as our initial project, and then we'll click create. Update set. I hope we're all following. If we're not, I can slow down. All right. So now that we've created our data set in Vortex AI. So now that we've created our data set in Vortex AI, let's import our table. Now we could either upload that CSV file from our computer, but I like to maintain connectivity. So we could either use Google Cloud, Google Cloud Storage, but we haven't set that up either. But what we have set up is we've uploaded our files to BigQuery. So we'll select a table from BigQuery or view, and then we'll browse BigQuery. We'll see all the tables that we have in our data set. Okay, so I'm guessing I spelled it wrong, so this is how I know. Okay, so we import our train data. All right, so we import our train data, and then just like that, it is reference, right? So we'll click continue, and there we have it. We have our data that we uploaded in BigQuery. We have that in Vortex AI. Now, like I said, we're not writing any code. We're just walking through the UI and trying to train a model, right? So now that we see our data, let's look at it. We analyze it, the integers, the different data formats, right? Date, string, float. And this is basically our schema. So this is what we have in our table, yeah. So we have dates column, family. The family is just the different categories of products that our client sells, right? This is the ID. So this is the numbers 1 to 2000, whatever length of rows that we have in our data set. This is our target. So this is what we're trying to predict, sales, right? This is our important one. This is what we're really trying to predict. The series identifier is basically it's some form of feature engineering. And what we try to do with this is we're trying to combine this column and this column together so that our model can easily track the ID and the store number together, right? So our column can easily track what ID belongs to what store number. So the store numbers go from, I think, 1 to 27. So we're just combining ID number 1 and store number 1, ID number 2, store number 2, ID number 3, store number 4. This just helps our model learn better from basically easy correlation, and it helps our model learn better. All right, so now we've seen what's in our table. We need to also determine what the series identifier column is. So because it's a forecasting model we're developing, these two features, right, are very important. So we're going to determine what our series identifier column is. So we can either use ID. Now, ID is not the same throughout because is either 1, 2, 3, 4 down to the end of the rows. So we could use that as our series identifier because it's just like our unique key, right? That's the word for it. But because I want to, help our model learn better, I developed the series ID. Now, you don't worry too much about it. I've already done this in a pre-processing stage, and all we need to do is just click series ID. So now our model knows that this is our series identifier column, our series ID, and then our timestamp column. This is naturally just the date because that's what we use to track our dates across the different rows in the project, right? So we'll click our dates. Now I've identified the two major columns in our data set. All right, now we're going to do, you can see it's popped up here. Now we're going to train our model. Before we had to write SQL code, now we're just clicking a button. So and we would have even had to write some Python, but what AutoML, so now we're going to try and train our model, right? Look at the first one, our data set is already clicked. So that's our forecast data set, right? Which is what we developed. And then we'll pick the model training method. So all these ones are different model training methods, and they're good, right? But today we're going to focus on AutoML. And what AutoML does is it helps us run the entire training process. All the frameworks I talked about, PyTorch, TensorFlow, we don't have to write out the code. We don't even have to see the hidden layers, any of that. We just need to click on AutoML, and it runs the entire training process for us, right? And you can use the different ones depending on the type of model you're training or depending on the type of use case. We'll focus on AutoML today, right? And then we can even custom train. So if we decided to now use our Python or skitlearn or PyTorch framework, we can decide to custom train. And that's when the engineer will manually have to write those codes one after the other. We're not doing that. We're just going to do AutoML. I'm going to click continue. All right, so now we're going to train a new model, right? And then we'll name our model. We do it model 1. We can write a short description, but there's no need. So what is our target column? I mentioned before that our target column is our sales. So always just know that your target column is the column you're trying to predict. What values are you trying to predict? And for us, for this project, it's sales, right? So we'll click that. We already determined our series identifier. We already determined our uh, timestamp column. We could also perform some more feature engineering. Our time column, our date column currently works as day by day, right? But if you wanted to do it bi-weekly or monthly, we could do that using some basic code and feature engineering. But for this, we're going to leave it as it is and just use the dates day by day as it is in our file. Now, the data granularity. Basically, it's trying to tell us how often, right, our data occurs in a sense. How often is our timestamp occurring, right? So our timestamp in this data occurs daily. So we use our daily data granularity. So because if you do it 1 minute, it will take a longer time to train your model. But I like to make sure that whatever date format that I've picked is how I determine my data granularity, right? So I choose daily. You can leave holiday regions as it is. Then the forecast horizon, how far into the future do you want your model to predict? Ideally, we'll just use 7. So that's like 7 days, 7 hours, 7 months. And then the context window is, we say you double the context window or triple it. So you triple the amount of the forecast horizon, you just triple it in your context window. So your model has a larger range to analyze from and, gives you better results. So either double it or triple it. And I usually go for 30. And then we can export the test data set to BigQuery, but we won't do that now. But if you decided to do that, right, all you need to do is click this, right? And then click on test data. My bad. Click on test data, right? And then you change the name. So basically what this does is it allows our the automates our test prediction. So it will create test data set for us. So instead of using the one that we created, Google Cloud or Vertex AI creates test data that we can use to test our model with. Okay. So sorry. I hope we're all following. And if there's anything I can slow down. All right. So we can do that. And then once our model trains, our test data is saved into our BigQuery folder, and we'll see that after the class. All right, so let's click continue. And then now this we need to pay a lot of attention to this training options page, right? As you can see, this is what we have in our database. We have our date, family ID, sales, series ID, store number, our series identifier, the target, and the timestamp column. All right, so if you look on the next column, we have transformation. So our date is obviously time, so we'll leave it as timestamp. The family is categorical because there are different categoricals of products that we're selling. So we'll do it categorical, right? The ID, we'll leave that as automatic. Sales, numeric, store number, automatic as well. And then you see feature type. So when they say feature type, it's basically saying what type of data is this? Is it a data that changes constantly, or is it a constant data? Is it the same throughout, or does it change constantly? So you see your data is changing constantly, so is it covariant type of feature type? Your family too is either it could be the attribute or covariant because it changes, but at the same time, there's only a limited categories that we have. So I'll keep it at attributes because there's only about about 22 different categories in this data set, 25 different categories in the data set. All right, so the ID too, it changes because you're not going to have the same ID throughout. And then the store number, we'll leave it as attribute because there are different stores, but all of them, yeah, they're different stores, but each number represents one store. So we'll leave it like that. And then we look at the available ad forecast. So we need to know what information do we require to make a forecast. Our date is important, so we'll leave it as available. Our family is important, so we'll leave it as available. The ID is important, so we'll put it as available. We're going to leave this as non-available because this is what we're trying to predict. All right. And then we'll leave our store number available as well. All right. With that said, we click on the advanced options. So now we're trying to determine the best optimization step. Now, I briefly mentioned the different types of loss functions that we have, but after our training our model is complete, I'll walk us through what they mean, and then you can really understand how they affect the entire machine learning work cycle. So we'll pick mean absolute error because that tracks the absolute difference between our predicted value and the actual value. So what that means is that when you go into testing, after a test, your model will produce its predictions, and then you compare those predictions to the values in the test folder, right? And I think I showed you what that looks like in the last week. So basically, we're trying to see the difference between what our model got and what the true value is. So we pick mean absolute error, and then we'll leave this as no weighted column, and then we continue. So we pick one. So this is just the maximum number of node hour, no, maximum number of node hours that we need. All right. And it's usually just best to start as one. And if your model needs a lot more hours to train, it will naturally just upscale and train till it's done. So we'll click one and we can start training. And that's it. We have a training model training in our US data location, right? So this is going to take a while. It's just going to take a while. And so unfortunately, we will not be able to see that now. But what I've done is ahead of time, I decided to train a model in a different location. And so we can see what it looks like after we've trained our models. Okay. So this is our data set. So we'll move to our trainings or yeah. Yeah. So if we go to training, right, we can see what we have in training right now, right? And if this is the model that we just trained. So this is model we're training right now. As you can see, it's pending training pipeline. The duration, we don't know yet, but we'll get on it, right? So if we open it, we can see the more details of our model and what the optimization is, the objective, the algorithm we're using to train, and other important variables, right? But like I said, we won't be able to see this training complete in this class. So we'll just go straight to a model that I have already trained in our model registry. So we went from data set to training, and now we'll check our model registry. All right, so let's see what models we have in our registry. And my other location should have the models that I've trained. As you can see, we have two models that we've trained, and this is the most recent one. So I'll open this one. Now, this is what happens after the training process is completed, right? We can now see the model, and then we'll try to evaluate and see how it performed, how the training went, and if we need to make further iterations to our training data set, if we need to, you know, fix a couple more things, right? So as you can see now, we have our target column sales, our mean absolute error is high, our mean absolute percentage error is also high. This is also high, this is high, and this is okay, right? I'll explain what they all mean. And then the feature importance. Now, this tells us what feature has the most influence on training our data set. As you can see, family has the most important effect or the most important effect on our database, right? So family and then the store number and then the date. So now you can see this. So I'll explain now what the different metrics and evaluation metrics mean for us and how we can determine if our model did well or not. We won't be able to push our model to an endpoint for predictions in this class, but by the time I come again in other classes and then classes to come, I will be ready to really show you how you deploy a model to the endpoint, and then you make predictions, and then we'll see how a model is actually faring using the actual tables. But today we're just going to look at the evaluation metrics, and then we'll determine if our model did well or not. So if we start with the MAE, which is our mean absolute error, ideally the goal is to make sure that all our metrics are on zero, right? Except the R square, right? Naturally for R square, it's better if the closer to one it is, the better, right? So our absolute mean says that we have 2.8283.529, which is honestly a moderate error, but it means our predictions are going to be off by that much. Naturally, we want this figure to be zero. All of them, we want them to be as close to zero as possible. But as you can see, we're far off. It means that our model needs some more training, or we need to either fine tune our data that we're training with, or we need to get more data, or we need to even change our training algorithm. So instead of using auto ML, maybe we design our own training sequence, right? But then our R square is basically just tells us how well our model performed. And a 0.5 is okay, but ideally we want 0.8, 0.9, and so on. So by the looks of it, our model has it's the first training, so I wouldn't say it's production ready or deployment ready. I think personally, from my point of view, with a couple more iterations, more trainings, we can determine the version right here. So we can train a new version. So I'll show you that after this. So you see that it's still too far off and we need to work on our data or train our model a bit more. So let's say we wanted to now train the same model to make it better, right? We would upload our data set again. So we'll come back here, click on our data set, train a new model, right? Now, if we decide to custom, custom, but we're not going to do that. So we'll train a new model, and then instead of training a new model, we'll train a new version. So we're training a new version of one of the models we already predicted. And this is after we uploaded a different file to it, right? A different type of data or more detailed data or a data that has more feature engineering involved in it. And then your target column is sales, same thing. Data granular, I'll pick it at daily. All right. I'll focus horizon 7, context 30, and then we'll run the entire training process again, right? We're not going to do that now. So this is it if you want to train a different version. And if we had run that and we come back to our model registry and we click on this, we can see version 2 right here. Version 2 will pop up right here, and then we can now interact with that different version. And if we're lucky, if we're done it better, our evaluation should be so much better, right? So with that being said, you should have a model in training on your training pipeline, and it's going to load. It might take a while, it might not, but it will just keep training until it's done. As you can see, this has been training for 3 minutes now, and it will keep going until it's done. So like I said, in the next classes to come, we'll evaluate, we'll track, we'll make predictions with our models, and we can better see. So with that, I would say that's the end, but I will briefly walk us through the idea for our assessment. And after that, that is the end for this class. And I hope that we have been able to learn and understand what services Google Platform provides us and how we can make our own models as efficiently as we would like. 1 second. So as you can see, we ran a slide prediction after the training of that model that I did. And you can see our predicted sales compared to our actual sales in that day. And you can see our model is far off. So which means that we just need to train our model better so we can get better predictions. All right. And that said, I'll just walk us briefly through our assignment, our assessment. So like I said, we just need to copy the SQL codes from here. Step 4, open a new query. All right, create a new query file. All right, and paste it into it. And copy it. So, so we'll just copy it from here, paste, and we can run our SQL files. But you remember you had to put your project ID into this, the name of your data set. You can name your views whatever you want, but it's better to just save it as train view. So once you click this and you run, you should be able to create a view of your data set. You know what? I'll just run this so you can see that it runs. All right, so my project ID is and then my forecast data set. Okay, so it has to be, so my data set name is AIAS class. And I'll create a train view, right? Okay, so I need to even specify. So after my class, I'll specify my table, which is the forecast test table, right? Forecast, yeah, train table, right? So after that, you just do dot forecast train data dot. So this last part is the name of the view that you're creating. So you're saying create a view in my project, in my data set, in my data set, and then from this table, I don't think you need to do this actually. Okay, no, sorry. So create my project, create it in this data set. I want you to create this file. So you're going to create this file in this location, right? And you're going to create this file from this table, my train. So I'll just finish it and I'll run it. So you can just copy this, paste it here, all right? And then call it dot train. Yeah, for yeah, forecast train data. So you're saying create this view from this table. Yeah. So it should run. Okay. All right, it should run and we should have our view created just right here. There you go. So now we have our view. So it's just a different look of what our table is. And this one has days of the week. So like I said, if you want to feature engineer your date, so you have more detail. So what day of the week was it? Using the code that was in this. Yeah, so using the code, you see this, select all, extract day of the week from date as day of the week. So we added a new column, extract months from dates as months. Like that. So it's basic SQL, if you can understand. SQL is very easy and straightforward. It's like English. So you just need to understand what the different commands work for. All right, so with that said, I think we've come to the end of today's class. I really hope you are following along. If not, I hope you understand and you can just go back into the videos and really, really understand the services what that Google Cloud platform provides. I hope we've had a good session and we understand. I will conclude with walking through a few more slides and then that is us for today. All right, so common issues in machine learning, missing features, we talked about this. And I also want us to pay attention to security. So it's the internet. It's anything can really happen. So make sure you know what frameworks you're using. Make sure you monitor your applications. Make sure there's traceability and it prevents you from threat. And the future of machine learning is automating the tedious parts. So let's make sure we can focus on the more, brain tasking events and leave all the repetitive actions to AI and machine learning. Any questions before we end? Hello, guys. Any questions? All right. Well, that is me. I thank you for joining us today. I hope you look forward to the next class. I can guarantee that it will be very informative. It will be a good session. My colleague will definitely walk you through it as efficiently as possible. All right, then. I'm very glad. It's good. All right, then. So that said, I'll stop sharing my class and I'll hand it over to our host for today. Thank you, Marvin. I'm glad. I'm glad I could help, Jessica. I'm glad you could learn from today. We'll just kindly hold on for a little bit more. Our host will be joining us.
I don't think our host knows you are done.
All right, well, I
Good
think I'll just
afternoon,
go ahead.
everyone. Okay.
No, it's all right. Please go ahead.
Okay, good afternoon, everyone. The host is not on seat right now. Please, let's try to fill in the attendance form and and our feedback form also. So we see you in the next class, which is next week, Friday. Thank you.
All right, then. Have a good week. See you next week. Thank you all. Enjoy the holiday.